Hi guys, welcome to Learning Electronics Repair. I have some motherboards here. These were sent by a subscriber. It says, hi Rich, 3 times motherboards, 1 with the suspected VRM, 2 MOSFETs dead short, other unknown, and other with INT fault. You mean intermittent fault? Guessing. So I have 3 motherboards, all of the same type, I think, and these are from a subscriber, as I say, named Martin. So hi Martin, if you're watching, get into the comments and let us know what's what with these motherboards. I can say what I know about them. So apparently these are using some sort of equipment that runs some software that effectively only works on these motherboards. I believe the developers of the software are no longer around. I don't know how they locked to these boards. I think he said they run under Windows XP in actual fact. So basically if he can't get any more of these boards, and he says they're very hard to find, extremely hard to find, or in some way get the software to work on something else, he's a bit stuck. Yeah, that's the top and bottom of it. So the first one we have here, this says works then fails or hard drive error. That is probably extremely difficult to try and repair, to be quite honest. Yeah, that's probably one of the hardest faults you can have because it's so intermittent. It could be just about anything really. Okay, the board looks in pretty good condition. So these are PCIe plus PCI. What's special about these? I don't know. Model EL336, or maybe there's another model number on these. Couple of RAM in that one. Obviously this is some sort of 775, is there something else? Oh, Core 2 Duo, okay, so it is a 775 machine motherboard. A couple of extra Molex on there, but it still has the 12 volt connector to the square one as well. No markings on this side of the board. Revision A. And that's about it really. I'm not sure who made these things. Maybe it will become clear as I look around them. EL336. What else do we have? So this one doesn't have any paperwork with this one to say anything. Okay. And this one, again, it doesn't say anything, there's no paperwork. So one of these 2 has short circuit high side MOSFETs apparently. That should be fairly easy to determine. So ground and then into the little 4-way connector. Well, that one doesn't have a short. Okay. Other one? Must be. Let's have a look. This one doesn't have a short either. Okay. How about this one? No. Oh, it doesn't say high side, it just says 2 MOSFETs dead short, so it could be low side. With the CPU in, this might read quite low anyway. Let's have a look. So we can see we have 1, 2, 3 phases here, 3 inductors. Each phase has 4 MOSFETs, so there's 2 high side and 2 low side. Quickly figure out which one is which. So we'll go to continuity on resistance. That's the 12 volts coming in here. So we can say then that the source of these 2 will be ground. I would think. Yeah, and then the junction is here to here. Is that short? It reads low, but I'd expect it to read low with the CPU in anyway. Let's get the CPU out. Okay. Yeah, that now reads high. It's going to normal ohms range. Open. No, not open, but it's quite a high resistance. Okay. Look at the other ones. This is the one that works anyway, or sort of, so we'll use that as a kind of a reference for the other ones. Okay. This one. Let's see. Ground. That's not short either. That's probably the CPU again. Take it out. Okay. That's climbing up. Yeah. About 700 ohms, something like that. How did that compare with the first one I had? I'll just check again. The V core, which is from these VRMs, as well as being the CPU, will provide at least one of the power rails for the North Bridge as well. So what's it read without a CPU in? Climbing up. It's about the same, yeah. So we can at least say they're both about the same. The last one, so is this obviously going to be the one with the short? Yeah, I'd say obviously there's only one left. So again, no. That reads quite a bit higher resistance. Oh, it's a different sort of CPU. This is a dual core. That's a Core 2 Duo, and this was a Core 2 Duo. This is a dual core as well. Okay. I think this one has a bent pin. Yeah, it's now climbing high. Yeah, behaving like the others. I'm sorry, Martin, but I don't see the short. Maybe it all will become clear. Let's look at this socket. This looks bad. There. So this has one bent pin in the socket. I'm not going to mess with that just like this. I'm going to get under the optical microscope so I can straighten that one. I'll just make a note of which one is which. So this one we'll just put pin. So I know that one actually has the bent pin, okay? Well, I'm at it, I might as well just check the others. That one looks good. I think I better make a note of which CPU we have as well, because it's easy to get stuff mixed up. It might matter. So this one is the E8500. So E8500, okay. This one's an E5300. It may not matter, but it's good practice. And this last one is the one with the bent pin. This is a, what do we have? Another E5300. So I don't see any shorts on any of them. Let's see if we can fix that bent pin, and then let's try power these up and see what happens. Okay, so this looks quite badly bent. It's doubled all the way back on itself. It may snap, it could be quite tricky, but let's see if we can actually get this thing to come back into position. Okay. Well, just rotate it a little bit. I'm sorry the focus drifted a little bit. That's not perfect, but it's not bad. And the trick with these things when they've been bent as badly as that one is probably not to mess with them. Yeah, don't like overly try to fix it. If it's working, and it looks like it will work. So what we need to look at is actually the end of it, where that is, and how it sits in the grid. If you imagine like there's a square grid between each 4 pins, yeah, and that sits pretty well. So I'm not going to go any more than that with it, and often with this sort of thing it is best just to leave it alone if it's something like. Okay, let's try these boards. So ATX switch, there's no connector I can see for the speaker, but it has an on-board one. Power supply ready, switch on. I've just attached one of these Molex. I just measured them through, so the 5 volt goes to the 5 volt, the 12 goes to the 12. So it's just additional power basically. We can see the analyzer card. And we tried to start it and it doesn't start. That is acting like there's a short. This is the one with a bent pin, or had the bent pin, okay? So it kind of tried to start. It doesn't try again, so something definitely seemed to trip that one out. I will give it that. Just going to disconnect this. Power off again. Power on. Yeah, something's tripping this one out for sure. Okay, let's try the other ones. Okay, ready to go. This one has some RAM in it. Let's put the cooler on. Okay. This one, I would imagine, is going to boot because of the fault he's putting on it. Power on. This one does start. But doesn't seem to boot. Hold on, let me connect the monitor, that might help. Let's see again. Power on, start. Well, interestingly, this time it behaves differently. And all I did was put the monitor onto it, take it off again. Power on again. This seems to have an intermittent problem. Like it did effectively try to start the first time. Oh no, it did boot then. Let's go again. Start. Yeah, it takes a little while. There's no monitor attached, so I'm going to put the monitor back on. Okay. Start. Yep. Okay, it switched itself off. Switched itself back on again. This time it's going to start by the looks of it. Still no picture. Well, this is the one he says works and then fails on HDD error or in some other way. So take that one off a second. Switch it back on. Start. Does it boot without that fitted? It sounds like the BIOS has got control of the fan. I'm going to put a CMOS battery in if it doesn't boot up or give a picture. It's possible he took the batteries out for transit. I'm guessing he would have done. It switched itself off again, switched itself back on again. Got control of the fan speed. But no picture. Okay, battery on. Put this back in this time. Just switch the power supply off for a moment. Okay, on, start. Interesting, so it's got control of the fan speed, but I'm just getting all zeros. Okay, let it switch off, maybe it'll come on this time. Okay. Yeah, it's going to boot or something's happening. I mean, it's possible he's got these boards set in the BIOS to have the primary display as the PCI card maybe, and not the onboard one. But I'm not getting a picture of it. Okay, let's try the third one. In fact, to tell you what, before we do that, let's take the RAM out. So maybe the RAM's not sitting right, it's been in transit. Take the RAM out. Okay, again, on, start. Does effectively the same thing, switches off, switches back on. Doesn't seem to want to boot without the RAM, and that's unusual, I have to say, in itself. Yeah, that's an unusual thing to happen. Try it again once without the RAM. Okay. Restart it. Oh, and this time it started to boot and then went to 0. Okay, let's put one strip of RAM in. So it's actually a rather unusual way, I will say. Yeah, that sounded like it went in. So one strip, on, start. Okay. Booting. Won't go any further than B0. Okay, put the RAM in. Again, I'll just reset it a couple of times to make sure I'm happy it's inserted. Doesn't sound totally positive, that again. Okay, that sounded better. On. booting to some extent. B8. Doesn't go any further. Let's try this in the same sort of way. So there's no CMOS at the moment. I've just got one of these attached. I mean, I can attach them both. It's not a problem. Let's just see if I can get this one in there as well. Yeah, I can attach both of them. Power on. Start. This goes to a kind of a random code, 6F. Okay. I'll get another CMOS battery. Okay. Yep, 3.3 nearly. Power on. Start. Now it's on zeros. This one doesn't seem to have control of the fan. Let me try and switch it off with the button. See if it'll shut down. It does shut down. So the chipset's running to some extent. Again. So this one doesn't seem to boot at all. I got that first 6F, it was a static code, it was probably just some sort of random code that came up. Power it off, just make sure the thing is drained. I'm guessing this is a CMOS jumper. Without a manual for this, but it looks like it's right next to the battery, so it's a pretty good guess. Just short the CMOS to clear it, but the fact this had no battery and all the time it's taken to get here probably tells me the CMOS is cleared. Okay, back on, power on, zero. So this one effectively powers up but just doesn't boot, doesn't do anything. That's normally because the CPU is in reset or something. If you notice, the LEDs here are behaving differently on this one, so we have clock and frame, but we don't have reset on this one. So that one behaves differently. I have the CPU from the one that was kind of trying to boot up. Pop it into this one. They look quite clean. Yeah. Okay. The other one felt cold, like maybe there's no V-core on this one. We'll check. Okay. Power up. Start. Same. Right. Let's see if we have any V-core on this one. Ground, black lead. V-core is going to be on the tab of these low side MOSFETs. Okay. No, this one doesn't have V-core, so V-core is not coming up. Okay. Just a tiny little bit. So that's got no V-core, that's what's wrong with that one. That would suggest there's a problem with the chipset somewhere or the controller on the V-core. More likely the chipset, but we'll see. So this is a good one to try the thermal camera on. I've taken the heatsink off because with no V-core, this is going to be cold. Okay. Anything getting warm on this? Yes. That thing. Okay, that's the north bridge. Let's power this up again. Power on. power. So $40, 36 degrees, something getting warm down here, 43, 45. What is that? That's a MOSFET here. Okay, that's a MOSFET down there. 47 degrees. We'll have a look see what voltage on that in a minute. That is probably, I mean, that's probably providing power to this or to this. This is the clock generator, I would think. That north bridge is really quite warm considering this is not running, not clocking. Yeah, that's much warmer than it should be. Anything else? Another MOSFET down here. That one isn't particularly warm, although it's glowing red. It's telling me it's about 38 degrees. Oh, 40, 50, 49 or 50. That is something down here. Let's see. Oh. That's this chip. This one. Doesn't feel overly hot. This is definitely getting warm now. And that one. Okay. Certainly the boot up sequence on this will involve this chip. Yeah, this will be part of it. This one, and the SIO, which is down here in the corner. That's cold, by the way. I didn't use the camera, but that is cold. Right, so this is close to that. I wouldn't be surprised if that's one of the supply rails to this. Let's have a look. I think we can say this is some sort of voltage regulator, or it's being used as a voltage regulator. What do we have on it? That is cold, by the way. Actually, that's a little bit of warmth in that CPU now. The CPU has a little bit of warmth. So VCore. No, VCore is still down, but these processors have like probably more than one power rail. VCore being the main one. This is 1.2. Probably goes to that. 3.6. 1.5. Okay, well we can compare this with one of the other boards. So we know what we have. 3.6, 1.5, 1.2. Are there any low resistances around here? Obviously there's not a short, because if there was a short you wouldn't have a voltage rail. But is there any lowest resistances around here? Let's have a look. So well, that's about 9 ohms. That's high. That's high. So I think we can say the one that's the lowest resistance is probably the output at 1.2 volts. And that goes to the CPU. And now it's reading 100. So that is involved in powering part of the CPU. It's one of the supply voltages to this, but not the VCore. This is the one that works and fails or has HD errors. I've taken the RAM out, so it's in basically the same as situation as the other one was we were just trying. So we'll use the thermal camera again. Let's see if I can see any particular difference between these, particularly how warm that thing's getting. Okay, so start. This is just saying 6F, it's not booting like the other one wasn't, basically. So look at this north bridge, which is, well, my finger's on it. So that isn't getting hot on this one. That's the clock generator we can see down there. It's just restarted by itself. It's going to all zeros. And that MOSFET, which is getting very hot on the other one, which is here. Find my finger, it's there. It's actually cold on this one. And something else here. Say this was the clock gen chip. That's 55, 56 on this one. Yeah, I think we can say pretty much that first one has a faulty north bridge because it's getting hot, as is this regulator, which seems to have about 1.2 volts coming out. What's it giving on this one? Let's just check. So volts, same regulator. Yeah, 1.2 volts, the same. 1.5, this was 3.3 or something like that. Yeah, 3.7, it's 3.6. So that isn't getting hot on this one. This isn't getting hot either. I mean, it's warmed up a touch. Well, it's still only 36 degrees. It's been on for quite a while now. Okay, so that's the one that sometimes boots and sometimes doesn't boot. Seems to be very particular if there's any ramming, whether it'll boot or not. With the RAM back in. It's just switched itself off. Back on. Yeah, and it's booting, or to some extent. Okay. And we can see that this is not running anywhere near as warm. And that little MOSFET down there, which we know is a 1.2 volt supply, is not getting hot either. Yeah, 38 degrees. Okay, so board number 1, we can say this one has got a faulty north bridge, and that's, thinking about it, 1.2 will be supplying both of these, and that is just getting very hot. So in fact, you can even see coming from the output of this onto this big thick track, it goes into the part of the CPU. We can see then the V core also goes into here, so it's one of the supplies, we know that, and then it goes down here, big thick track, into this. So that absolutely confirms what that supplies. This is getting hot or hotter. That is getting much hotter. So I need no more evidence than that. This one has a faulty north bridge. I've taken the heatsink off the north bridge. We can see it now. Looks like a little bit of corrosion down here, but I think that's actually just dust. And also that's not in the direction of the voltage supply that's got a problem. Yeah, that's come off anyway. So we can see even clearer now. This is the MOSFET that's getting very warm. It's acting as a voltage regulator, so we have an output of 1.2 volts, we know that. Hard to get the camera to focus on that actually. It's probably just focusing on the two capacitors instead. Oh, it's one of these AO, Alpha Omega things, MOSFET of some sort, I can see it. No, I'm wrong. F logo for anti or Fairchild, you would think. Then AO9BZ, so that's the device, but we know the device is working okay. It's just something's drawing too much current from it, and there's something that's very clear now, so we know it goes under the CPU. We can see where the heavy track goes, and we can see exactly where it comes. So it comes down to here. In fact, I'm sure we would find if we look on these capacitors. we will have a direct connection, I would think, on at least one of them. Okay. Yep, that one. Other side will be ground. But we're just seeing the resistance of the device. Okay, we can actually measure that on another one without the CPU, and is the best bet. I don't think it's reading particularly low. Okay, 108. But let's get the thermal camera again now. Okay, so I'm pointing at the chip. The chip is cold. You might be able to see where it is. Just show you. So the chip is actually here. I've just touched the top of it there, so you can see where it is. Right, let's power this up and see what happens. So standby is on. Start. Look, and that's going straight away into the 40 odd degrees, okay? The MOSFET is warming up. $50 degrees, and again we can compare that with another one. Okay, and that's just with it powered up. Nothing happening, it isn't booting.